All right, so for this one, it says in Chapter 6, Exercise 32, we learned that an Office of Federal Housing Enterprise Oversight collects data on various aspects of housing costs around the United States. Here's a scatter plot by state of the housing index, or the housing cost index versus the median family income for the 50 states. The correlation coefficient is R equals 0.65. The mean housing cost index is 338.2 with a standard deviation of 116.55. That's pretty high. That's a very broad spread. Now, I want to interject here before I'm done reading this. Remember that in a normal distribution, the standard deviation is within about plus or minus 3 standard. Let me back up. The total distribution is within about plus or minus 3 standard deviations. In other words, I would take this 116, multiply it by 3, and then add that to the 338, and that would get me like the maximum value or close to it. If I'd multiply it by 3, multiply 116 by 3, and then subtract it, I'd have a negative value. So that's something that we got to look at and think about. But I'm not quite sure what the unit is for the 338.2. Anyways, it says that the mean median family income is 46,234 with a standard deviation of 7,000. Okay. Again, if I wanted to find the minimum value, I'd take that 7,072, multiply it by 3, and subtract that from the 46, and that would be an approximation. Okay. So anyways, here's a scatter plot of that data. Kind of looks like a straight line, especially right in here. It looks like a straight line, but as we get further and further out here, our points are a little bit, in other words, if I drew a straight line through here, some of these points would have a very high residual, like this one here, okay? So that's probably why the correlation coefficient is 0.65, okay? Because there's some points that are far from the line. Anyways, let's move on to the question. Is the regression analysis appropriate? Explain why. So, where's my little writer thingy? Oh, there it is. So let's explain it. So for A, is this appropriate? I would say yes. And the reason is the housing cost index and the median family income are quantitative. So that's the first thing. They're not qualitative, they're quantitative. The scatter plot itself not scatter plot. I always feel like I'm writing too slow, but then I have to remember that you guys are writing at the same time I'm writing. Usually I'm writing way faster than you guys are. The scatter plot is somewhat straight. It kind of looks like a straight line. It's not a perfect fit, but it's somewhat straight. I should probably note there are a few outliers. right? As the median family income increases. Now, what I mean by that is when I come over here, as we go to the right in this direction, in other words, my family median income increases, then the scatter plot tends to spread. Here it's a tighter fit. And then as we're in this region, if my line was here, I got some outliers that are kind of far apart. And I would even think of these as like outliers. And so, but we could still make a prediction because we know what the R squared and R value are. And then we can make, the data is still helpful, right? So if I crank through this and I expect the housing cost for somebody that makes $70,000 a year, my prediction will be somewhere in this region, right? But they might spend way more money, or they might, they could choose to spend less money. You know what I mean? It really depends on the individuals. But I have a base, and I have a way to measure about how far away from that base is. Okay? So that's part A. Part B, what is the equation for the housing cost index from the median income? So now this one we're going to have to do a little math. So remember, y hat is equal to the y-intercept, which we call b naught, plus the slope of the line, which is b sub 1, times the x value, okay? So now I got to figure out what b1 and b naught are. So b sub 1 is equal to rs of the housing index all over the standard deviation for the median income. So the R value for the housing cost index is 65. The standard deviation was that 116, what was it, 0.55? All over the standard deviation of the manufacturing, which was 7,700, or not 700, 7,072.47. All right. And so I'm going to plug that in my calculator if I can get it to pull up. Here's a calculator trick. I'm going to plug this in. Remember, when you're doing fractions on the calculator, it's not a bad idea to do parentheses for the numerator if it's more than one term, because that arranges the order of operations. You could think of the numerator. All that stuff needs to be done first. And then we're going to divide that by what's on the bottom. Now, I only have one term on the bottom, which is 7,072. Whoops. What was it? 47, right? Okay. Then I could just get this number, right? So it's 107. So let's put that away and plug this back in here. And so that value is 0.0107. Okay. Now for B naught, you could solve for B naught by using this equation. So let me find some space here. If I use my equation, let me come up here because I'll need a little bit of space. If I say y hat is equal to b naught plus b1 times x, I know that for my predicted value, I think they said it was 46 to 34, and that should be equal to b naught plus, now that we know what b1 is, b sub 1, it's 0.0107 times, oh wait, I did that backwards. This goes in here for x because that's the median income. This is 338, and I'll go back. You can't see it on the screen, but this is just from the data that they gave us in the problem. So this is 46234. So if we read the problem, they're saying that the mean housing cost index is 338, and then the mean for the manufacturing, that occurs when the median income, not manufacturing, the median family income is 46,234. So we're pulling this and this, plugging it into our equation to approximate what the y-intercept is. So when you do the math on this, basically we would multiply this times this, and then subtract it from this. You end up with b naught is equal to negative 156. And I'm not going to go through the algebra today. You could do that on your own time. All right? That's a simple linear equation that you solve for b naught. And then what does all this mean? So we were asked, what's the equation? So if I wanted to clean this up and use some verbiage that makes sense, I would say that the housing cost index, and I'm just using this equation here, should be equal to, and we would say the predicted housing cost index would be equal to negative 156.5 plus 0.0107 times the median family income. And that is the actual equation. Okay, so that was a lot. That was for part B. For part C, I bet you they ask us to make a prediction. Part C, stay with a median family income of 44,993. What would be the predicted housing cost index? So we're just going to use the same equation that we have here, right? So we're going to say that the predicted housing cost index, HCI hat, is equal to negative 156.50 plus 0.0107 times the I don't know why I keep saying manufacturing, median family income, which they gave us as 44,993. Okay, so then we got to crank through the math. Now again, I could just do this on my handy dandy calculator. So I'm going to say negative 156.50. You don't have to put the 0, but I'll do it. Plus 0.0107 times 44993. And so it's about $324.93. So the predicted housing income, HCI hat, is equal to $324 93. Okay. For part D, I bet they want us to make some sort of comparison of some sort. It says, for part D, it says Washington, D.C. has a median family income of this much and an HCI of this much. How far off from the prediction in part C from the actual HCI? So this is actual, observed, right, compared to the, so they're basically asking us the residual, right? So what we would do is, what do I do with that number? So we're going to take, our prediction was 324, right? And then we got to do the 498.02. So we would say the observed minus the predicted, and that gives us the residual. So they had 548.02 minus the 324.93. And so, did I write that down right? Because the math doesn't seem to be. Yeah, it does. All right. So, again, we'll just do that on the calculator. I'm going to say, what was it, 548.02 minus 324.93. So you get 223.09. So, oops. Now remember, if it's positive, it's an underestimate. That means that the predicted value was too low. If I do that same math and I get a negative value, that means it's an overestimate, which means that the predicted value was too high. All right, let's see what E is. Oh, there's F. It goes all the way to F, huh? E, it says, if we standardize both variables, what would be the regression equation that fits the model of standardized housing income, housing cost index from the standardized median family income? Well, the z-scores would have that same relationship. So let me think of how I would write that. We would say that, because the correlation, so for E, the correlation of the slope that relates to z-score, so the regression equation would be z prime, or z hat of the housing cost index, the z-score, predicted z-score, would be equal to 0.065 z of the median family income. So that's the relationship. That's what, and that comes from the given R value, this right here. Now we don't have to know what those actually are, but if we crank through the math, that's how we would find that. And then for part F, it asks the same question, but now it says if we standardize both variables, what would be the regression equation that predicts the standardized median income? And it's the same thing except we flip-flop it. So for F, the correlation of the slope of the regression line relates to z-scores, so that the regression equation would be z hat the median family income is equal to, actually the same exact thing, 6 find the z-score of HCI. Okay? Is there any questions on that? Okay. That was a good one.